Hi, welcome to StatStuff. I'm Matt Hansen. This lesson is part of an extended series on hypothesis testing in the analyze phase. In this lesson, I'll review a chart that can guide you in finding the right statistical test for your hypothesis testing. This chart can be used as a reference for all future hypothesis testing that you'll be doing. It would help you if you've at least reviewed the prior lessons on hypothesis testing before viewing this lesson. But for now, let's talk about how to find the right statistical test.
Well, it's essential that we find the right statistical test for what we're going to be doing our analysis on. So because of that, in order to figure that out, it really depends on the type of data that we have and what we're analyzing to figure out which is the right statistical test for us to use. So what I'm going to show you next is a chart that I like to use in order to figure out what is the ideal statistical test for the hypothesis testing I'll be running. Now, to preface this, you might want to consider again the transfer function, where it's y equals f of x, where you have some output metric of y that is what you're comparing your x to, and that way you can see, is that x, is that input factor something that is a root cause that's driving that y? Well, so that means you have an x factor and you also have a y factor, two things that you're comparing to each other. So based off of that, the first question we want to ask ourselves is the data type for both of these values, the x and the y, are both of those values continuous? Well, if they're not both continuous, then the next question we want to ask yourself is the data type for both values discrete? Well, if both data values are not discrete, then we're going to go in one path, but if they are both discrete, then we're going to find ourselves going down this path. We're going to be testing for proportions. And by testing for proportions, there's several different tests we're going to use going down that path. Again, this is when we have both values, the x and the y, that are both proportions and both discrete values. When we're comparing one type of value, one metric, to a standard, like a target or a goal or something like that, we're going to use the one proportion test. But if we're comparing two groups, like one thing to another thing, to do different areas or regions or locations, or two different types of products, or whatever it is we're comparing, if it's one thing to another, then we're going to use a two proportions test. But if we have multiple factors that we're using, then we're going to use a chi-square test. Again, these are the tests that we'll use that when we're trying to measure proportions to see if there's a statistical difference between the proportions of these groups that we're analyzing. Now in this case, if we had answered here that the data type for both of these values are not both discrete, and we'd already previously answered that they're not both continuous, then that tells us one of them is continuous and the other one's discrete. Well, in that case, we're going to go down this path. Then the next thing we need to ask ourselves is what is it that we're measuring? Are we measuring for central tendency, or are we measuring for spread? Well, let's assume now in this case we're going down the path of central tendency that we're measuring. We're looking for like the means or the averages, that is the medians or things like that, to look at the central tendency for the distribution between different groups that we're comparing. Well, if we go down that path, then the next question we need to ask ourselves is the data normal? If the data is normal, then when we're doing this comparison between one to a standard, like a target or a goal, then we're going to use a one sample t-test. But if we're comparing between two different groups, then we're going to use either a two sample t-test or a paired t-test. And if it's more than two factors that we're comparing, then we're going to use a one-way ANOVA test. Now, if we answered this question saying that no, the data is not normal, it's a non-normal distribution, and then when we're comparing one value to a standard, again like a target or a goal, then we're going to use a one sample Wilcoxon test or a one sample sign test. But if we're comparing between two different groups, we're going to use the Mann-Whitney test. But if there's multiple factors that are being involved when we have a non-normal distribution, then we would use the Moods median test or the kruskal-wallis test. Now, this is for the test related to central tendency, but if we're measuring instead spread, then we'll find ourselves going down this path. Again, when we're comparing one value to a standard, like a target or a goal, we're going to use the one variance test. But if it's one to one, again between two different types of things that we're comparing, then we're going to use the two variance test. But if it's multiple factors that we're comparing, we're going to use the test for equal variances, which is also called the homogeneity of variance test, or HOV. Now, if we go back to our original question, if we answered yes, that the data type for both of these values we're comparing are both continuous, then we're going to find ourselves using relationship types of tests. Now, for relationship types of tests, if we're comparing between two separate values, one to another, then we're going to be using either the Pearson correlation or like a fitted line plot. But if there are multiple factors that are involved when we're testing for relationships, which could also to some degree include some discrete values. Well, if they're all continuous values, we'll use a multiple regression, but if there are some discrete values, then we can get away with using the GLM, or the general linear model.
All right, before we close this lesson, let's discuss how we can apply some of these concepts in a practical way.
Well, I'd like you to refer back to the critical metric, or that output y, as well as the 5 factors, at least the minimum of 5 factors that you might have selected in a previous lesson for preparing us for doing some hypothesis testing. Based off of those factors and the metric that you had selected, I'd like you to go back to the chart that we've reviewed in this lesson and figure out what are the statistical tests that you would possibly use for your analysis. In order to figure out if you're going down the path of central tendency, which will be a good thing to look at if you at least have one continuous value, then you may need to run a normality test as well on the output y in order to figure out which specific test you might find yourself going down. But try to do it for all those factors to see which test you might use for each one of those different factors in order to figure out what would be the ideal test for hypothesis testing.
Well, that wraps up this lesson. Check out StatStuff.com for many more resources that can help you achieve powerful results. I'm Matt Hansen. Thanks for watching.